Welcome sa ating Physical Science Lesson Discussion. This video contains our Lesson 1, Formation of Heavy Elements. It is in line with the most essential learning competency, which is give evidence for and describe the formation of heavier elements during star formation and evolution. We have here the following objectives. At the end of the video, you will be able to define stellar nucleosynthesis or fusion, identify processes that led to the formation of elements during stellar nucleosynthesis. Simulan natin ang ating leksyon sa origin of our universe. There are several theories trying to explain the origin of our universe, but let's focus on the most acceptable theory, and that is the Big Bang Theory. Big Bang Theory states that the universe originated billions of years ago in a rapid expansion from a single point of nearly infinite energy density. Lagi lang nating tatandaan that Big Bang Theory is about rapid expansion of this infinite energy. And this rapid expansion causes this energy to spread across space in all directions. Isa sa mga common misconceptions na naituro sa atin is that Big Bang talks about violent explosion. Ulitin ko, itinuro sa atin noon na ang Big Bang daw is about violent explosion of this infinite energy, which is not. It is only about rapid expansion of infinite energy. There are four stages of Big Bang. Those are singularity, inflation, nucleosynthesis, and recombination. Magsimula tayo sa singularity. Singularity is defined as a single point containing all the energy and space-time of the universe. Uulitin ko, singularity ay tumutukoy sa single point na naglalaman ng lahat ng enerhiya at space-time ng ating universe. Ang ikalawang stage ay tumutukoy sa inflation or extreme rapid expansion. Ulitin ko, inflation is the extreme rapid expansion of all the energy and space-time of the universe. Ang inflation mismo ay ang mabilisang paglawak. Mas mabilis pa sa kisap mata ang kanyang paglawak. Kaya nga ang universe sa wikang Filipino is kalawakan. Ang ikatlong stage ay tumutukoy sa nucleosynthesis. Nucleosynthesis is the process of light element formation. And during this stage, deuterium or an isotope of hydrogen were formed. The first two elements formed during this stage are helium and hydrogen. But because during this stage is mainit pa mismo, this causes the light elements to ionize, separating electrons to its nucleus. Hanggang sa umabot na sa recombination. Mula sa mainit, lumamig na ang temperatura during Big Bang. Yung temperature or the decrease in temperature causes the electrons to combine with the nucleus. Uulitin ko, habang bumababa ang temperatura, electrons combine with the nucleus. Lagi lang nating tatandaan that the first two elements formed during the Big Bang are hydrogen and helium. And these two elements are very important for the next slides. Pero ano nga ba yung elements na tinatawag? Elements are pure substances that cannot be broken down by chemical means. And these elements consist of atom. Atoms are particularly made of another subatomic particles. These three subatomic particles are protons, which is positive in charge. We have your neutron, which is neutral in charge or walang charge, and we have electron, which is negative in charge. Ulitin ko, meron tayong tatlong subatomic particles na bumubuo sa ating atom. Those are proton, which is positive, neutron, which is zero or neutral in charge, electron, which is negative in charge. Lagi lang natin tatandaan na si proton at neutron ay makikita sa nucleus ng atom. Ulitin ko, saan makikita sina proton and neutron? Sa nucleus ng atom. Para sa kaalaman ng lahat, ang nucleus ay tumutukoy sa parte ng atom or yung gitna ng atom. And yung electron ay makikita mismo sa ating orbit. Now let's familiarize ourselves with the following terms: star or stellar evolution. Star-stellar evolution is a process by which a star changes over a change of time. The next term is stellar nucleosynthesis. Stellar nucleosynthesis is a process of forming elements inside the stars. Stellar means star. The next term is nuclear fusion. Nuclear fusion is a reaction in which two or more light elements combine to form heavier ones. Ulitin ko, nuclear fusion is a reaction in which two or more light elements combine to form heavier ones. From light elements to heavier ones. Now let's take a look to the life cycle of a star. A star starts from a nebula. This nebula is a cloud made of gas and dust. Again, nebula is a cloud that is made of gas and dust. And this gas and dust contracts due to the gravity of a nebula and produces the main sequence stars. Main sequence stars ang tawag sa mga stars na gumagamit ng hydrogen as energy source to produce light and heat. Then these stars evolves into either red giant or red supergiant. And then red giant evolves into planetary nebula and into a white dwarf. Yung red supergiant naman evolves into a supernova and then either into a neutron star or into a black hole. And we have here the diagram showing the different processes that occurs inside the stars. Example, in main sequence stars, we have the proton-proton chain reaction in the CNO cycle. Inside the red giant stars and red supergiant stars, we have the triple alpha process, alpha ladder, and the S process. In supernova, we have the R process. Let's start with the first process that occurs inside the main sequence stars. We have the proton-proton chain reaction. Proton-proton chain reaction is a process by which average stars gets their energy by converting hydrogen into helium. Uulitin ko, proton-proton chain reaction is converting hydrogen into helium. It starts with a proton and a neutron fused together to form deuterium. Then one proton collides with deuterium to form helium-3. And then two helium-3 collide with each other to form helium-4. The process is what we call proton-proton chain reaction. Now let's take a look in this picture. We have protons and neutrons, for example, collide to each other to form deuterium. And then another proton collides with our deuterium to form helium-3. And then two helium-3 collide with each other to form helium-4. Now let's proceed to the second process that occurs inside the main sequence stars. We have the CNO cycle. CNO cycle stands for carbon, nitrogen, oxygen cycle. So this process is used by massive star or stars 8 times larger than our sun. And this process converts hydrogen into helium. CNO cycle is used by massive stars by converting hydrogen into helium. Let's expand our understanding in CNO cycle. CNO cycle ang tawag sa process na ito because we started from carbon-12 as our catalyst in converting hydrogen into helium. Carbon-12 have 6 protons and 6 neutrons. The next step is the addition of a proton. A proton were added into carbon-12. So there will be a production of 7 protons and 6 neutrons. So 7 is the atomic number of the element nitrogen, and the mass is 13 because 7 protons plus 6 neutrons will give us 13. Next step is the conversion of a proton. A proton from our nitrogen will be converted into a neutron. So 7 minus 1 will give us 6. We only have 6 protons, and 6 plus 1 neutron will give us 7. 7 neutrons. So we will have carbon with an atomic mass of 13. 6 plus 7 is 13. Next step is addition of proton to our carbon 13. So there will be 7 protons now and 7 neutrons. 7 plus 7 will give us 14. And 7 is the atomic number of the element nitrogen. Next step is the addition of a proton to our nitrogen 14. So 7 plus 1 will give us 8. And then our neutron is still 7. 8 plus 7 will give us 15. And 8 is the atomic number of the element oxygen. Next step is the conversion of a proton. So a proton here will be converted into a neutron. Again, a proton will be converted into a neutron. So this will give us 7 and then 8 neutrons. So this will give us nitrogen with the atomic number of 15, because 7 plus 8 will give us 15. Next step is addition of a proton. So a proton from a hydrogen will be added to our nitrogen 15, and this will break down nitrogen 15 into carbon 12 and into helium 4. So we will have 6 protons and 6 neutrons to our carbon. We go back to our carbon, thus calling it CNO cycle. Again, CNO cycle is a process by converting hydrogen into helium. The next process we have is what we call the triple alpha process, or also known as the tri-alpha process. This process happens in red giant star once they leave the stage of main sequence star. Main sequence stars are stars that uses hydrogen as their source of energy. So kapag naubos ng lahat ng hydrogen sa core ng star, it is time for them to use helium that are converted into carbon. Ang tawag sa kanya, triple alpha, because 3 helium-4 ang ginamit. Helium with atomic number 2, atomic mass 4, is also known as the alpha particle. So we have here an illustration showing 3 alpha particles producing carbon 12. So we have the first alpha particle combined with another alpha particle producing beryllium 8. And the last alpha particle combined to beryllium 8 produces carbon 12. After triple alpha process, there is another process called alpha ladder. As long as star generates energy, it accumulates more mass or mas bumibigat ito at mas lalong lumalaki hanggang sa maging red supergiant. Sa loob mismo ng star or sa core nito, nagkakaroon ng alpha particle fusion that creates heavy elements up to iron. Again, this process is what we call the alpha ladder because there is an alpha particle fusion. Magsisimula tayo sa carbon 12-6. This element was fused with an alpha particle to produce the element oxygen 16-8. This element oxygen 16-8 was later used to fuse with another alpha particle to produce neon 2010. And then, this neon 2010 was also fused with another alpha particle to produce the element magnesium 2412. The process keeps on going hanggang sa mabuo natin yung element na iron. The next process we have is what we call neutron capture. So how do elements heavier than iron form? Take note that as the energy at the core of the star decreases, nuclear fusion cannot produce elements heavier than iron. So there is a different pathway needed for heavier elements to be formed. And those are S process and R process. Pag sinabing S process, it means slow rate of capturing neutron compared to its radioactive decay. Therefore, it only increased the number of proton by only 1. Pag sinabing R process naman, it means there is a faster rate of capturing neutron compared to its radioactive decay. So mas maraming neutrons ang nagko-combine sa nucleus ng atom. This happens during supernova forming heavier elements than iron with a process known as supernova nucleosynthesis. So in summary, we have here stellar fusion or stellar nucleosynthesis that occurs in main sequence stars which form helium primarily through proton-proton chain reaction and CNO cycle. And then these main sequence stars evolve into red giant or red supergiant stars which form elements primarily through triple alpha process, alpha ladder, and S process. And in our supernova nucleosynthesis, this occurs during supernova explosion, which form elements heavier than iron through our process. Thank you so much for watching. And that ends our lesson discussion in physical science.